Hello, everybody. Welcome to the community call for May of the Internet of Production Alliance. I am about to launch the PowerPoint. We are here today with two speakers. And unlike how we usually do things, we're going to start with the speakers and then close on the updates. For two reasons. One is that some of the speakers need to head out. And two, because after the call, we're continuing the conversation with anyone who wants to discuss the governance of the Internet of Production Alliance, but that will be like after this hour, and that enables us to segue better into that. So a reminder that we've shared, this should work here, that we have community notes. We have a notepad on which you can be writing notes from today, where you'll also write your links, comments, documents that we've been talked about. Everything will be there and accessible afterwards. And I'd encourage you to put your name in there and some social media handles. Up to you if you want to put your email, because this is a public document. So but yeah, please do write your comments and notes in there. It's helpful if we're many doing that. Without much more time, I would like to hand over to our first speaker, who is Nathan. I believe, Sarah, you'll also be pitching in if your connectivity helps. Yes. Is helpful. But basically, Nathan, I'm handing over to you to tell us about the changes that we're doing and how we work with open know-how, which is one of the first things that we worked on. Mm-hmm. So hand over and let me know when you want me to change the slide.
Okay. I mean, this is fine. I don't really have any slides. So hello, everyone. So for our few guests here, to set the stage, get everyone up on the same page. Open know-how was the first of a family of open data standards that we started developing a number of years ago as a way of representing all of the information that was needed to create any piece of open hardware. The idea was to make these designs portable and interoperable, a frequent problem in anyone dealing with open hardware systems. We saw this a lot, in particular in the sort of supply chain breakdowns of the early COVID pandemic, when everyone was suddenly trying to engineer new, biomedical devices to deal with the lack of, the fact that you couldn't get ventilators for love or money, for example. But suddenly everyone was realizing that they had to not just invent a new device, but also a new way of communicating how to build that device to the people halfway around the world. Our work on it thus far has been wide-ranging, and it is a very deep problem to explore. But part of the problem has been boiling the ocean. How to define how to create anything anywhere by anyone out of any material is not a good way to actually solve this problem. And while it has yielded some interesting explorations, it hasn't really gotten a lot of traction. So. Oh, yeah, there you go. That's it. Basically what I've been proposing and what we're doing with standard at this point is refocusing in, the idea being that, stand by. The coffee machine is doing the thing. Thank you. So basically the idea is, rather than trying to solve this problem in as universal a way as possible, I think it's important that we zoom in on a specific use case for a specific community that has a specific problem, and try to solve that. So even if it's only 10 people, if we can solve that problem so well that those people are actively using it and spreading it to their community, that is a success. We can spread from there. So part of the goal of this call and subsequent calls is to work with the community and identify problems that they have that could be solved by a specific application of this kind of standard, and to develop the standard and the tooling around it to solve their problem. We have a couple ideas that we've already been working with sort of internally. Myself and Sarah have been discussing one in particular that I'll share with you in a minute, but we also wanted to open this up to the community to see if there's something else that we can help you with in this regard. The idea that we've been discussing is, there are libraries all over the US and around the world that have maker spaces built into them. These libraries, each, how to put it, the use case we discussed is basically if someone comes to, a library / makerspace and says, we want, we're looking for a project that meets these criteria to teach, to help students develop this thing. Right now, there is no way to search and share that information. The library at Rice University can't say, oh yeah, let me see if any of the libraries at any schools around, any schools in the network have a project that meets these criteria and all of the documentation that you can just go do with it. Nothing like that exists. It is a fairly low-hanging fruit, but I think it would be a really valuable contribution, and it would, start building this thing up. One other note, and then I noticed, Sarah, that you had made a comment. So if you want to jump in, give me just a second, and then I'll turn it over to you. One other piece about this is thinking about this in terms of a tech stack. There is the standard by itself is not actually useful. There is that it is the bottom layer of a stack that actually builds towards useful tools that people will actually engage with. So you have your standard. On top of the standard, you have low-level tooling, like simple command line, single function tooling that allows you to interact with that standard in specific ways. As you roll up from those basic tools, you have an engine. You have, if anyone's familiar with something like kubectl, these command line tools that have a number of possible commands that give you a bunch of things you can do within this space, but it is still there's no graphical interface. This is still a low-level tool, but it is a collection of tools that all allow you to operate against this standard. From there, then you can start building services that allow you to actually take, an interface for a customer or user-facing problem that communicates to this engine via API and then sends something back. And then above services, you have a platform that rolls a number of services together, both from this engine and other things. And that's where you actually have, the sort of a final product. It's my view that until we at the IOPA can develop at bare minimum an engine composed of tools that allow people to interact with these standards, we're not going to get very far in terms of engagement. So the goal moving forward is to work with the community, define specific problems that can be solved with tooling that we can develop based on applications of these standards. Develop the engines that they need in order to solve their problems. So that is my spiel. Sarah, did you have anything you wanted to add?
Yes, absolutely. And again, apologies for the connectivity issues because of my very interesting location. Can you hear me okay?
Yeah, no worries.
Yeah, okay, great. So I know that this link is in the Framapad, but I'm just going to bring it back to the forefront by putting it into chat. For those who are not already familiar with, Open Know-How as it was originally released, because I know that, not everybody has the same history here. And just to contextualize a little bit, from my perspective, I'm relatively new to the IOP and coming from a background of as an academic researcher and working with data standards, metadata standards, and as an academic research librarian, I came into this work basically conducting a study. I was contracted to conduct a study that speaks to what Nathan was just describing, which is, this was the original specification that was put forth, back in 2018, 2019. And now we want to have conversations with the community about how it's being used. We want to take a look at, what are the use cases, what's the adoption rate, what can we do to continue the support. And it became clear to me at that time, and this research wrapped last year, and the reports are available on the community forum, and we could share those back. that it was much more about a conversation surrounding processes that would allow to identify, what the community needs are, and let the community decide what the work streams would be in order to engage with that standard. And so that's really where the conversation is moving today, and what what Nathan and I have been discussing, what I've been discussing with other members of the IOP about it, that the juncture at which we are finding ourselves currently is as looking at OKH, open know-how, as a part of like this stack, and looking at how can we do the best good for the community. It may be time to transition to a different approach. And so sorry about the doors opening and closing. Does it sound like I'm in a haunted house? It does a little bit. Yeah.
But in a cool.
Academia is still haunting me. That's what it is. So in that sense, oh, hi, James. So in that sense, as Nathan was talking about, a specific work stream that could be viable and for discussion within the community, my focus and my role with the IOP, I engage in a lot of research, and my background is in education and data and whatnot. But as a part of the secretariat of the IOP, I'm really looking at what is the mechanism, what is the vehicle that'll help move these conversations forward. And so that is a part of what this discussion is, from my perspective and from Nathan's as well, is that if we were to take a look at OKH, instead of being like, hey, here is this standard, how do we make people use it? Because that's not what it's about. It's, if we look at this sharing of knowledge openly, or specifically for sharing global knowledge and P2P localized production, how can we support a process to convene these conversations to help support the community? And so one of the documents I wanted to share that's a part of this is one that Nathan and I put together. I'm going to put it in the chat again, because I don't know if screen share is actually going to work well. But it essentially covers, just in brief, of this is the problem that we were originally working with, and under the original remit of the work that the organization set out to do, we are suggesting that it's time to, rather than focus on maintaining this standard, it's time to focus on the sharing of open knowledge more as of an initiative. And these are the types of people that we feel would benefit moving the conversation forward. It's not just folks who have the technical expertise, but we're looking at educators, we're looking at other community members. If we are going to get to a place where this is to meet the original goal of being of the greatest use to the larger community, and we're going to start gathering documentation of use cases, this is that framework that we see for transitioning basically the composition and intent of the working group that has been dedicated to OKH for the past, how long has that been? Again, I only joined the IOP at the end of last year.
Been a minute.
It's been a minute, yeah. But yeah, I mean, to also preface this with that, I'm new within this particular group, but I've had a lot of experience in working with open everything development, or open software, open educational resources, data sets, and also working with consortia and open governance models and whatnot. And it's it is time to transition in order to look at a sustainable model, and the kind of growth that has been in conversation for the past several months. Mm-hmm. And so I guess then I would pose it back to you, Nathan, that within this, I mean, in moving this forward, I would be curious to see, and I, of course, can share a visualization of like how the actual governance structure would work and et cetera, and et cetera. But I think that the most interesting part to the people joining this call really is, what does that look, what could that look like for me? And what would I want it to look like for me? So I'm not going to go into like, this is how this amazing mural board I put together looks. I want to hear, with the understanding of what it is that this was the original intent and what we set out to do, how could this be structured to get folks involved and ultimately supported to get done what they need to get done?
Mm-hmm. I think it's a good question. I mean, I realize I'm kind of bringing the biases and framings of the sort of professional world I occupy, which is very different from academia and research. So take with as much salt as you like, but in my mind, this is to again coming back to this notion of the tech stack. This is useful when there is like you can think of this as a product. This is not necessarily a commercial product, but this is a product. Until those tools exist, we're not going to get this. This is not going to be a useful thing that we're spending our time on. And I think if we want those tools to exist, we have to think of them as a product, and we need stakeholders. We need someone who speaks for the users of this product. And so our community is small enough right now that I don't think we need a wildly complicated governance structure to select that. I think people can really self-select. If there's anyone here on this call or as part of the larger community who's like, yes, we have this problem, and a thing that allows us to interact with open hardware standards in our particular use case in this way would be super useful, then we should just be like, great, you are now the stakeholder in this product development initiative. We need someone who can serve as like the product owner, who can speak to the challenges and the use cases that you have, and we need to connect them with a team whose job is to develop along those lines. That is my 2 cents about how this should be developed. I realize that that's not necessarily how things work in the academic context, but that's my thoughts on it. Anyone else? Bueller? Anyone?
I mean, from a manufacturing standpoint, or I guess my viewpoint is manufacturing at this point. So I do a lot of, I'm looking for, and we'll probably be developing a series of documentation standards for distributing manufacturing information among different manufacturers. Normally this is considered to be like information about how to basically put together an object or a device, how to basically use the tooling, how to basically make the tooling. And then the one challenge is normally this is held by the manufacturer and then not shared back to the original producer. But what I would need to do is create a framework and a rationale for why the manufacturer needs to contribute this information back to the original developer. And the reason being is that normally this is considered to be like trade secrets, intellectual property. But the truth of the matter is that in a global distributed framework, you need to have this information shared because this is the information that is key to actually making things and making them cheaply and effective. And it actually is also part of trust in the supply chain. If you trust that the best practices and methods are being implemented and the easiest are being implemented for your product, then you can also have a high confidence in the quality of manufacturing. So what I think there's 2 different things that would be useful for me right now. One would be a certification program for, and this is similar to how like OSHWA does it and how UL does it and how a lot of other certification bodies do it. But a certification program particularly designed to encourage manufacturers to open up and give back their information to get a rating based on the quality of their participation. UL does this currently with their product lines to maintain confidence in the supply chain for safety and for make sure that things that shouldn't be in the supply chain don't make their way in. Normally for almost primarily for safety, but I think a similar model would work for manufacturing in general for open documentation and open manufacturability.
So when you say open manufacturability, can you elaborate a bit on what you mean in that context?
Sure. So let's say I'm making a widget, and that widget's made using a combination of processes. Let's say 3D printers. 3D printers is a good example. Everybody knows how 3D printers work. Everybody knows like there's a billion versions of them. So let's say that I'm making a 3D printer. I have the design files, all the 3D printed files, but there's a lot of information about how I assemble it, what materials I use to assemble it, what tooling and fixturing I use to make it easier and cheaper. And that information is normally held by the manufacturer and is considered to be intellectual property and trade secrets. For example, Prusa doesn't tell you how they make their 3D printers, even if they put out the design files for all the 3D printed parts.
The Prusa does provide really excellent instructions. I built one of theirs from a kit, and it was really.
Yes, but I mean, but you know what I'm talking about. They don't tell you how they set up their printing farm for making all those individual 3D printed parts.
Right. Yeah.
They also don't tell you what the tooling is. So Prusa is probably a better example, but you get the feeling that like you want more people working like that in a collaborative environment, and you want to basically make it a selling point from the consumer standpoint that they can say, okay, this party is actually doing this. I want to buy from them because I know that I'll get a consistent product across the entire manufacturer. Ideally, you'd also have like people building Prusas that aren't just Prusa,
right? But
they're all playing in the same pool where they're all equal in terms of like producing, giving back, and creating a body of documents that is useful for making locally manufactured, distributed, globally distributed products. So right now, and the problem that a lot of the market is seeing is that there's no enforcement mechanism, there's no feedback mechanism to highlight. You really almost need like a YouTube video or a YouTuber to like just sit around and do nothing but like bash bad manufacturers and praise good ones. You need that public platform and stick to really get a good like distribution of like both high quality material, goods and services, as well as a fair and open marketplace. The music industry and the guitar effects pedal industry has seen a lot of this because they're a more mature industry. I think the 3D printing industry is just getting into this because they sort of from a standpoint of everything being opened, and it's looking like it's going to be harder and harder to keep that as the manufacturing processes get more and more complex.
Yeah.
So I think the manufacturability is going to be a larger and larger part of the overall documentation source that's currently not being covered by the existing, I guess, culture of open documentation. Anyways, that's my 2 cents.
Thank you, Sarah, you had a comment?
Oh, I did notice that Barbara had her hands up. So
I just wanted to mention that this idea of like feeding back, that rang a bell with the research that was done on electronic component on one of the reasons for like possibly influencing repairability and like standards around electronic components was that might feed into the R&D cycle. And Alex will speak to that.
Yeah, absolutely. So I don't want to take too much time away from that, and I do want to give Peter a chance to talk. I'll just mention very briefly. Again, Lauren said that issue of documentation and also quality assurance has come up again and again and again. in conversations. It is a dearth. It is recognized. One of the things that I had just noted with Nathan is that in the UX testing that I did as a part of the MVP tooling that was developed as a part of open know-how for the portability of design files and whatnot, like when it got down to the user testing, everybody provided that feedback of like, hey, where's the documentation and instructions? And it had nothing to do with what we had developed. It's basically every system that we were pulling to the design files from that hold open source product design files, like none of them really linked to solid documentation. And so that is widely recognized. And that's a big part of all of these ongoing conversations about quality assurance, particularly for medical devices. So I'll just leave it there and hand it over to Peter.
Thank you. A couple of thoughts here, and it's like a mixed bag of reactions. I mean, having spent 15 years in the makerspace and Found Lab world, I've come across like every day across the topic of documentation, and everybody wants documentation, but not everybody is so keen to produce documentation. You've all seen that, and there is no silver bullet to that yet, or maybe will never come. That's an issue to address. So really, the contributor side to documentation is an issue. Another thing, just butterflying on you. I haven't read this open know-how maintenance to initiative proposal in full, but I guess an issue there just technically is to think about platform or federated systems, and obviously the way to go is federated systems. I guess everybody here in the call would agree. I see Nathan thumbs up. Yes, of course. But then when we talk about quality assurance, manufacturability, that's to me, that's really kind of worms, because what does quality assurance and quality standards really mean? So for instance, I did at the Open Knowledge Festival in Helsinki, I invited an American artist to bring his project of a self-made CNC milling machine made of standard sheet materials. So he came from America to Finland, and the first thing we had to convert is imperial to metric, and then we had to find out that standard plywood sheets are different per country. Now that's on the amateur level. I've worked with the Dutch military on setting up military bases in peacekeeping operations. So the Dutch military is bound to the Dutch building standards. So when they want to use steel in Africa, they can't get the steel quality they're required to use. So they were looking for different ways to build bases to circumvent this sort of quality assurance standard. Now, I mean, that's getting back to the question of quality assurance and manufacturability, where you probably need to sort of, in a way, in a smart way, interconnect standardizing quality assurance and manufacturability ideas, but interconnect that with local abilities. And that would be local abilities in terms of geographical distribution, as in the case of raw materials available and manufacturing capabilities available. But it could also be in like in the same city, where you have more advanced manufacturing facilities with advanced CNC machining, and others with more hand tools, which raises really different questions of manufacturability. And I think that's a bit for me from a research standpoint, it's a very interesting challenge, which we need to solve in practice. So that's my 3 or 4 points that I'd like to add to the discussion.
Thank you, Peter. I think that's a very familiar set of problems for anyone who's been working in makerspaces.
I'm gonna call time and hand over the presentation to Alex. We usually leave the conversation open after the calls to continue them. So we can do that. There's another room that will be open for the governance conversations, so we can do the two streams at the same time. Alex, I'm handing over to you. I had a nice slide, but I think I can just hand the mic over to you.
I'll
right?
receive that baton
There you go.
and crack on. Well, what I was thinking and following on the back of that conversation, I'll very quickly introduce who I am and what I've been doing, and actually segue right into this conversation about documentation, because I've actually kind of been working on this. So I'm Alex. I'm more from a design background, sort of classical industrial design background, but I've been working with the Internet of Production in the capacity as a consultant, doing some research and interviews to scope out the potential development of a materials and components standard. Now, that's quite an unwieldy remit, all of materials and components in the world. So a lot of the work that I've been doing for the last couple of months is deciding which limbs to chop off and to really limit what the scope of this thing might be. So I think what I'll do, I've got some points that I wanted to talk about in terms of stakeholders I've identified and kind of use cases. But actually, I want to, while the pan's still hot, loop back to this conversation that both Lawrence and Peter have touched on. So one of the use cases for kind of working with materials is verification. So I, as the designer, specify, here's my design and I need it to conform to this grade of material, or I need you to have this component standard. 90% of open source projects, that kind of thing doesn't matter. You can add a little bit, but there are some, in the case of these kind of, say, the respirators or kind of products where safety, reliability, and so on are engineered needs, then conformity is important, and then being able to verify that your producers are using the materials that you specified. Now, in traditional industry, if I, as a designer or a producer, order a part from a fabricator, they will send to me an inspection certificate which tells me exactly which elements are in the material that I've ordered and what standard that conforms to. And they own the liability of this part is made of the material that you asked for. Now, in a distributed context, that's very difficult because I, as the designer, am not in direct communication with the fabricator. There could be 100 different fabricators in 100 different locations. So the idea that I'm floating, and this is now going out to a conversation, what might a distributed inspection certificate look like? So I've put up my design. It's a distributed concept, and perhaps some kind of framework or system could be devised for, okay, I need this thing to be made to this material grade. If you don't make it to this material grade, fine, that's you've made one for your own house. But if you want it to be certified in some way, if you need it to be branded in some way, then you need to accept the liability that I asked for it to be made from this material and you have produced it to that material. So I don't know what that looks like on the data end. Like I said, I'm a designer. I'm not a sort of code type, but that was something that kind of emerged from my research. How does maybe because I think both Peter and Lawrence had some really interesting comments on this documentation aspect. So I think I'll open up that and then loop back to my work.
So let me tell you how it works in industry with dealing with change notes. So this happens in the aerospace industry a lot when dealing with the FAA. What happens is that okay, so let's say you've got a part that is no longer manufactured anymore. The FAA, this is in thousands of airplanes all across the world, and you need to be able to make new ones or repair it. This isn't the perfect way to do it, but what the FAA does is they allow for remanufacturability, reverse engineering of that part. And basically there's a conversation that happens between a manufacturer and the FAA, which is basically acting as a regulatory governing body. The FAA hires and employs engineers that are supposed to be experts in the field. That what they do is they create a conversation and a dialogue where the manufacturer will produce a qualifying evidence saying that their production and their device or their materials and methods meet the satisfactory requirements to make as previously produced product part as equivalent to what was originally manufactured and produced. So in this particular use case, you need to have this is maybe where the IOP could come in, but you need to have a regulatory body that can basically have on staff an engineer that can take a look at deviations in the manufacturability process and make a informed, educated decision, as well as make a documented decision on what parts, what devices, and what changes need to be made to make it manufacturability in a local context. The key part there is that it needs to be well documented and open for review, because the problem, and this happens in all industries, and it's harder to do in private industry as opposed to a public industry, but not every engineer is going to be able to catch all the use cases for where it might fail. A great example is using different grades in plastics. You may find a perfectly adequate plastic substitute, but because of maybe contamination issues, it's not actually applicable for the application you intend to use it for. And so being able to have that open to comment and maybe correction, and maybe making it more of a pull request style, make it easier for people to like put up objections. Would make it an easier way to basically catch the faults as they come across.
Yeah, I think that's you're not only parceling in the documentation, but you're parceling in the actual methodology for how that would be checked, right? Who is the referee in this game, and how is it going to be done? And I'm thinking, kind of relating it back to the work that I've been doing, the remit has been materials and components. So I think in this case, it might actually be more feasible to check the tolerancing of a component rather than the chemical makeup of a material, right? If the IOP is going to certify this kind of documentation, and as you say, have an engineer on staff to check these things or do audits at times, it's going to be a lot more kind of doable to sit there with a vernier and kind of check tolerance than it is to get all the machinery needed to check the chemical composition of something. So there's a feasibility aspect to this as well, which I think is a limiting factor, as well as the documentation.
So this is where a spot checking and random auditing comes into play. This is also where the roasting of manufacturers comes in as well. So what you do is you would take a random sample of product and you buy them. There's a YouTube video or YouTube channel called Project Farm, which is a good example of what they do with this as a hobbyist or as a semi-professional industry. What he does is he basically he takes community submitted ideas, and he reviews to the best of his ability variety of manufacturers, and he purchases them himself from a variety of different sources, and then he compares them against each other in a kind of like in a ordered fashion. And in this way, you can probably do like a roundup of manufacturers on a semi-annually or semi-yearly basis. And then that way you can, if you randomize the detection process, you won't catch 90% of the issues, but you will catch the glaring, like where they basically decide to completely switch over from using like a high grade medical grade resin to using a low grade contaminated resin. And what it becomes is it becomes a so in compliance, there's a concept of total observability versus a fear of detection. So what happens is that when you have the ability to spot check your work, the fear of detection keeps you in line and keeps you compliant. Now, there may be deviations in product quality, but as long as you can keep everybody working towards the same goal, it's effective. Having total observability of the entire tool chain means you have to actually add in more deviation places, because what happens is that when you have total observability, there's a lot of manufacturable defects that would normally just get sloshed into the manufacturing that I think get caught, but then cause burdens to the manufacturer to keep things moving. This happens a lot in the medical marijuana industry, because they've got total observability of the product from grow beginning to end, and it creates a giant industrial burden to maintain total visibility of that industry. So I think compliance is going to be device and implementation specific, and the requirements are going to differ based on the needs of the industry. Not everything needs to be totally observable. Not everything can be spot checked. Like baby formula, for example. If you have like a bad batch of baby formula, you have a major problem. And catching it once every 3 years is not going to be acceptable.
No, I think this contextualization of where it is the compliance is going to be implemented and so on is really important, because I mean, in this context, the application of an aluminium profile is very different from, say, leather, right? It's a totally different kind of industry, a totally different supply chain. I'm just going to hijack the conversation a little bit and relate back to what I've been doing for the last 2 months. One of the things that I wanted to identify in order to help frame what a materials and component standard might need to do is a series of use cases. So I have 5 use cases, and they follow a kind of pseudo circular material flow. So I've got discovery, selection, specification, verification, and identification. I'll break that down. There's no test after this. So discovery, what could this design be made of, right? If I'm designing a product, I need to look out there on the market of materials and see what's available to me. How do I know what's out there? What material data do I have access to? Selection, a lot of engineering reference books will have kind of flow charts and decision trees for how it is you should get to a material choice. Also, what material data you have available to you changes your choices, cost as well as engineering properties. Specification, how do I communicate to the fabricator what it is that I need it to be made of? So that's essentially the whole documentation issue. Verification, how do I know that they've done it? And then identification, I wanted to kind of close the loop and say, if I'm a maker, or if I'm kind of drawing upon a recycled material flow, how do I know that the material I have in my hand is compliant with the material that has been specified, right? If I want to use, say, recycled PLA and make my own filament, how do I know that what I'm holding is PLA? So there's several different use cases for what a material standard intervention from the IOP could be. Each of them could be a different standard, and within that you've got a vast amount of materials and components that you could intervene with. So just kind of breaking it down, materials, components, and 5 different use cases, that's 10 different standards, right? So there's a lot of scope, and my work essentially has been how to encircle that. In terms of sort of databases and what material data is out there for free, there is actually pretty good coverage already. I mean, a lot of the advice I was getting from interviewees, I've been interviewing stakeholders and so on, is don't reinvent the wheel. You know, there's already material databases, there's already component databases. Anyone involved with electronics will know Octopart. Anyone who does physical kind of mechanical design will know platforms like Trace Parts. There's a bunch of these platforms already. Some of them are freemium models, some of them are paid, some of them are kind of just free websites. So there's no point kind of making a new database of material data unless it has a specific function, right? Which goes back to this conversation of which industry are we targeting, what use case, what not just stakeholder group, but you know, precise evangelical makers are going to adopt this thing. Yeah, and maybe just to wrap up kind of on the deliverables of what I'm doing, I said that I would have a report out by today. That's not ready today, so my most deepest, sincerest apologies. But I wanted to kind of maybe wrap in some of the notes from this conversation into the findings. That will be shared on the forum. There's a forum on the Internet of Production community. There's a subsection for materials and components. So yeah. That's basically me. There's much more I can go into, but I'm conscious of time and would like to send it to questions.
We're going to be saying goodbye to. He already dropped off. Okay.
That's
Questions? There's 1 minute left, but we're not going to close the call. So if anyone is able to stay, you're very welcome to. And just to announce that Max, who is our tech coordinator, will take over the hosting at some point, so I can slip into another call.
So I'd like to slip in just one last remark. And you already mentioned you know, recycled PLA or whatever, recycled materials. That surely opens up another enormous kind of worms with material tracking, and certainly in plastics, where we don't know what the additives are, which are the most nasty stuffs in plastics, and you know, get accumulated through recycling processes and maybe re-added. So really, there is a serious quality and health issue at hand. While we all strive for these ideas of circular economy, and that's an absolute conundrum, very interesting to think about and work on.
I think one very concrete kind of touch point with this identification aspect is there are already standards for labeling plastics, right? Any kind of pick up any injection molded plastic thing and it will have a triangle with a number on the back. Now, if that could be kind of promoted in open source hardware and in 3D printed parts, then, you know, at least within the Fab Lab context, if you see a 3D printed widget in the bin, you might have a better clue as to whether it's ABS or PLA. Yeah. That's a very, very low key point of intervention, but it could help.
Yeah. I have to get going. Everyone, thank you for showing up. Pleasure.
And so I'm gonna turn off the recording in any case. Thank you very much, both Alex and Nathan, for speaking to this. The recording stops now.
Yeah. So yeah, thanks. It's been really interesting, yeah, listening in on the thoughts and ideas. And I think one of the things that I find really interesting is sort of how this idea of quality assurance has sort of become sort of center stage in this conversation as well. And I think part of the work that we're doing with, you know, I think we gave a very brief history of sort of, you know, where things started. But I'd be interested in exploring sort of a couple of ideas with you if you have a bit of time. So I just wanted to see, you know, just get a gauge of how much, like, would you be okay for another 10 minutes or so, or would you?
Yeah, kind of max, because You guys still
I
got
can do 10 minutes max.
Yeah. Okay. So yeah, as I said, the quality assurance thing is really interesting, and I think there are lots of different ways in which that can be approached. I think from a sort of in terms of the way that we're structuring things, again, historically, as we touched on before, sort of there was this effort to sort of create this documentation, this standard for specifically geared towards what we call discoverability, sort of to help, as Nathan was saying, to help find projects based on certain criteria. But what we're doing is sort of revamping things so that we can actually figure out in like what are the use cases and how can we as a community come together to sort of solve more specific use cases perhaps than these sort of more and see from the specific what we can generalize, rather than, I think the original approach was sort of let's look at the general thing and try and fix it. And in that context, when it comes to quality, for example, there are roughly, I mean, one way of looking at it, the way I see it, is that we've got the quality of documentation, which we touched on, is like, the quality documentation is, is the documentation written in a way that actually, so that if I hand you this document, it's enough for you to be able to reproduce the thing. There's also the quality of the finished product, which is what we've spent a lot of time talking about today. There's also, Alex, you touched on the quality of the materials. For example, so there, I mean, even the quality in itself is, in my view, at least 4 or 5 different work streams. And it's really, what we're trying to do is really identify what these work streams are, who in the community is interested in like really getting into the weeds on those very specific detailed use cases. And on a bigger level, it's like figuring, so for example, the way we've categorized it before is that the quality assurance side on the finished product is more to do with the people who are working on sort of the contracting side of distributed manufacturing, because it's been seen historically within the IPA as a contractual issue, is, are you giving me what I paid for? Whereas the documentation quality or the quality of the design files are, like, can I take these design files and actually send them to a manufacturer and get the thing done? Are they, or are there errors in the design? That kind of quality issue is seen more within OKH, which is sort of the documentation and design area of work. So I think part of this conversation is trying to sort of tease apart who's, how we're going to actually tease this whole thing apart, and how we're going to create these more specific task forces, essentially, that are working on the very specific areas. Peter, I really want to hear what you want to say, but I just want to sort of highlight one thing in that context, which is that there are, and as many of you have already said, there is already a lot of work that's going on. I mean, ISO alone has so many different standards related to additive manufacturing, including some of the stuff that you've talked about. There's things there's developing standards on the determining particle chemical emissions from 3D printer extrusions, for example, and there's other ones to do with acceptance tests for laser metal powder bed fusion metal machines and stuff. I mean, they're very, you end up having to be very, very specific on these things at some point. And the approach we're trying to take is, if somebody like the ISO is already working on something like this, can we take that work that's already been done and see how applicable it is to distributed manufacturing? Because obviously ISO isn't looking at it specifically in the context. Some of it might be, some of it might not be. With medical devices, which come up a lot, I mean, there's ISO 13485, which is, again, specifically quality assurance for medical devices. So, can we take that and adapt it, or adopt it rather? Or are the needs for distributed manufacturing so different that ISO standards don't apply? That's also part of the work that we're looking to do. So it's not just about like building these standards, but also seeing how we can take what other people have done and apply it to this context. So the question I have is sort of, how interested are you in getting involved in these conversations, and which ones of these conversations might you see yourself more interested in?
Yeah, so my take on this is, and I've worked a long time ago in quality assurance. There's this concept of standards and quality assurance is sort of a center out thing. We, the engineers know best. We define the standard, and everybody has to conform to that standard. with distributed manufacturing and you know, the thing I mentioned about materials and manufacturing capabilities, and essentially manufacturing in distributed cultures, there need to be an added other paradigm of quality assurance, which is outside in, which actually starts not with some institution opposing a standard with consumers, but on consumers taking responsibility and declaring their quality standards and work outside in. Of course, you know, when it's health and safety and chemicals and cancerogenious materials and all that shit, that applies to everyone. But you know, other aspects are really cultured and local. So I believe in quality assurance, as in questions about documentation, questions about manufacturability. There needs to be a combination of inside out and outside in. So really, you know, like platform or federated. Yes, we go for federated, but then we need to think that concept of federated through the whole ecosystem of distributed manufacturing.
I have a solution.
And it's easy to say that's needed, and it's not so easy to solve that puzzle.
I have a solution. You want to hear it?
Sure.
Yes, please.
Okay. So federated warranties. So this would be a group. This would be a. This is something I've been thinking about for some of the products I'm working on. But so the way the warranties are currently done is they don't work. And right now, a manufacturer produces a warranty, and a warranty is acting like a bond against the manufacturability defects in a product. So what happens is that, and the way this would be done is this would be a manufacturer would put up a chunk of money, and it would be used as part, and it would be part of the regulatory body as when they manufacture the product, and it would basically be pulled from for the lifetime of the product. So, and it would be periodically, think about a car, for example. A car has already have a manufacturer warranty for like 10 years. The manufacturer would put up a bond on the warranty of the product, and it pull from that warranty over a period of time. Now, it may not cover the lifetime of the car. A car may have a bunch of recalls, and the warranty gets completely consumed immediately. And then at the either the manufacturer may put more money up for the bond to fulfill the requirements of that warranty, or they may go out of business, or they may say that we can't support this anymore, and that this is a terrible decision, and we have to mitigate the risks as best we can. But creating a separate body, creating a warranty as a bond entity also allows other parties to pay into that warranty entity. And so what happens is that consumers themselves can actually start paying into a reoccurring, almost like an insurance program for the products that they own. And so that what would happen is that over time, the people would buy into maintenance of the bond warranty, and that bond warranty could be used to fund research, development, repairs, and continued support for that product. So, and the reason why so basically creating a separate vehicle for supporting products outside of the manufacturer is going to be really important for both the consumer to basically feed into, and this and as well as for distributed federated manufacturing to be able to support. So anyways, I don't know, I've not done it yet. I've not seen any use cases for how to do this, but that's my solution to that problem.
I really
Interesting.
like
Interesting. I would add repair capacity to the system in some way.
Well,
you know, not just the warranty money thing, but the repair as part of distributed manufacturing, distributed repair capacity.
Well, and that becomes there's a little bit of a feedback mechanism. So the car analogy works really well because the mechanic is hired by the owner of the car to do the work, to do the repair for that particular job, and insurance fraud is a huge issue, and there needs to be mechanisms to correct for fraud inside the system, because there's a lot of different ways for it to be for the bond insurance to basically get bled out. But I feel like those are problems that are well understood. But I think that like as long as the owner of the device is happy about the work performed, and there's a feedback mechanism so that the owner can say that this mechanic or did the job correctly and towards maybe an open standard, and that the standards that they produced were fed back into the body of knowledge that is represented by basically the warranty and the support and the warranty support mechanisms in place. Then I think you can create a feedback loop where you have a group of support technicians and engineers who are willing to work on projects that have funding based on a distributed. It'd almost be like creating a corporation just to support a product, and the corporation is owned by the people that own the product itself, and that you gain membership into this corporation by paying for a warranty and buying the product itself. And so it creates this kind of this corporation is like a legal entity that can basically make decisions on behalf of the group of owners of all these products. And it's almost like in real estate, this happens a lot, where a real estate developer will build a community like neighborhood or building or something like that, or a condo. And then the organization and maintenance of the condo is given to the owners of the condo or the neighborhood or the land entity that people actually live there. And the original real estate developer goes off to do another project. So I feel like this could be a model to create a self-regulating body. It has its own problems, but I think it can create a self-regulatory body to maintain product support over a lifetime of the product. Yeah, and I like it is this combination of, so as you said, sort of a bond and an insurance scheme of sorts, and I can see that in especially with Peter, the idea of adding repair sort of capabilities. Another way of seeing that is sort of even extending the warranty, for example, after a certain time, or even having I don't know, like a secondary market of extended warranty. So post, after the original manufacturer's warranty runs out, you might have other people who, are in the repair scene, for example, who can offer these extended warranties. I mean, it has so much potential to sort of for different use cases. I think it's definitely worth. I'd love to see this conversation continue. Basically,
jumping on the back of repair. So the last project that I worked on with Internet of Production was related to repairability, specifically for electronic components. But one of the sort of interesting recommendations, if you like, is trying to flip the economics of repair. Because the big issue is that once you've sold the product, it's then the transactions happened, and the value of repair is now an externality for the company. Whereas someone suggested this kind of repair as design intelligence. So if you can collect repair data, which parts are failing, how frequently are they failing, when did they fail after they were purchased, and so on, that data can then feed back into development and build better products. So now it's no longer an externality, it's an investment into product development by ensuring that you take care of the repair and capture the data.
Yeah, and I think that also requires a social movement for longevity in products. Because from the manufacturing standpoint, or from the capitalist standpoint, you don't get extra capital or money or sales from repairing your devices. You want a high turnover you want fast fashion, you want fast electronics or fast manufacturing to basically continually making the latest and greatest, because that's what sells. So I think we need to have you'd almost have to have a social and this may be something that can be combined with like ecological benefits, and then maybe like a call to like reliability, that you need to have a company that's interested in having long-lasting products and be able to advertise and showcase the value of having products that are reliable and long-lasting.
Yeah, definitely. And I mean, it sounds to me like this is a conversation. As I said, I mean, I think I speak on behalf of others in the community as well. I think this would definitely be a conversation that we'd like to see continuing. So, you know, if you're, you know, I just want to confirm if both of you are interested in, you know, if we were to look, what we're looking for really, as I said, is to sort of convene more frequently around certain topics to see how we can move them forward. I think the best, what we have in mind is to start with basically the use cases, and by talking about different use cases, and then within those use cases identifying the different areas of work that we want to work on. And I think this particular, I mean, starting with maybe putting something down. I don't know, Lawrence, if you have something that I mean, is there any documentation, for example, on this idea that you can share, maybe on the forum, and maybe we could start a conversation to see if we can start maybe convening some kind of conversation around a group that could get together and discuss this in more detail and see how it might fit into the wider work of the IOPA.
Sure. I've got some ideas jotted down on a Google Docs, and I think there's a continuation of another conversation we had at the Oshawa conference that we had earlier last month.
Mm-hmm.
So I think finding a good home for these ideas, I think, is really the key. And then, but I think I signed up on the forums. I think I put my email in the information, or the document in one of the chats. But I think that, like, having more, feel free to invite me, and maybe we can make a more consistent form for some of these things. I think adding in more manufacturing and more manufacturers into the conversation, and then also educating more manufacturers on why this is an issue and why it can help them both maintain profitability and also and help with some of the documentation burdens that they already have, is going to be really important, especially as a next generation of manufacturers come into play, who are looking at how to basically work in a distributed global economy, where they may not have some of the modes that existed 20 years ago or 10 years ago don't exist anymore. So
sorry, I need to leave. So thank you for that.
It did end up being a bit more,
very interesting conversation.
Yeah, thanks,
Peter. To continue that in some way. Thank you. Thank you so much.
I'll reach out to you. Yeah, thanks.
Sure. Thank you.
Thanks, Peter. Yeah, and thanks again, Lawrence, and thanks for bringing this idea to the table. As I said, I'd be really interested to see who, as you said, you know, I think it is about getting the manufacturers and the designers as well. You know, what comes to mind is, you know, we do have quite a few projects, especially within the context of open science hardware, for example, where, you know, you do have these extremely well-developed projects in terms of documentation, design, and they're being made in all of these different labs around the world. But there isn't a comprehensive, I mean, this idea of going to a university lab and saying, you know, we can help you with the help of local fabricators, make this thing locally at a much reduced cost than having to, you know, whether it's a microscope or other research equipment, and adding that layer of sort of reassurance that they won't then have to fix it themselves. You know, there is some kind of warranty if it fails, built into the system, would definitely be, you know, I can already think of quite a few projects within our community who'd really be interested in having this conversation.
Yeah, and the key takeaway is that, like, there's a big difference between saying I know I could make it and I want to make it.
Yeah.
because a lot of people like they look at some of these projects and they're like, yeah, that's awesome, I want to build it, and then they get halfway into it and they're like, this is not what I want to be doing. They want to use it, they want to have support for it, they want to have the confidence that they could maintain it if they needed to, but nobody really wants to I mean, only I think letting people subspecialize into the different aspects of it, and then also making sure that people know the value of what they're asking for, and be able to be transparent about what it costs to actually do some of these things, I think will be important. And I think that transparency in terms of costs and deliverables will be important as well going forward, because I think one of the downsides of the way we've distributed our capitalistic infrastructure is that we've created like federated markets that only loosely connect to each other. And the best example is that, like, you can go overseas and the same skill sets will cost you like pennies on the dollar versus going stateside and then trying to manufacture at basically higher labor rates. But we're also looking at a time and place where, as labor rates slowly decrease due to more mechanization of labor, we're actually going to see a inverse where we'll see an equalization of the labor rates as things become automated. Because what will happen is that like it won't be the cost for me to do the job, it'll be the cost for a machine to do the job. And then the cost for machines and materials are more unified across a global landscape, especially as the manufacturing as we get into more as we get into more automated manufacturing and more distributed automated micro manufacturing. And we're already kind of seeing some of that in the 3D printing space, because it doesn't, I mean, once you get the machine, it doesn't really matter where it's located. Other externalities become more important, like location, shipping, material transport, and other things like that.
And
I think
sort of the lifetime cost of the product. I think, in the context of this, I think this is one thing that a lot of sort of the traditional manufacturers have become quite good at being able to give you an idea of what the lifetime cost is, whether it's through the warranty scheme or other ways, so that you can get an idea of what the not only what the lifetime cost is, but also what your expected utility. Is this thing expected to last, as you were saying earlier? There's an expectation of it's expected to last 3 years or 10 years. And I think within the context of distributed manufacturing, having something along those lines, that would definitely be something that would really help people who make that choice feel that I think quite often it is that sort of, it's similar in some ways to the sort of the early days of open source software, where a lot of people sort of saw it as the sort of the cheaper sort of cousin of real software, so to speak. And it took a lot of time and effort and different successes and failures and different approaches before the open source software world landed where it is today, where it's it's second nature. Like it's actually in some context it's actually the other way around. Sort of, you don't trust software that isn't open source. And I know it's sort of, even though we're not necessarily exclusively talking about open source hardware, but I think that sort of paradigm of distributed or localized manufacturing being seen as sort of the the less desirable of the options, but the one that you go to because you can't afford the stuff that's made by the mainline manufacturers. I think that's part of that's part of the work we're trying to do is to change that.
If you've ever been involved in manufacturing, there's a lot of posturing in manufacturing to maintain your perceived quality in terms of actual product delivered.
Yeah.
And I think that the key point is that because manufacturing has for so long been it's who you know and it's where you're located, that as we get into distributed manufacturing, there's going to be a lot of resistance from existing manufacturers to the idea of basically cutting away their major differentiating factor, especially in government contracts, in defense, in things like that. Like, it doesn't really matter. I mean, the reason why you manufacture airplanes in America is not because that we make the best airplanes in the world. It's because we can control who can buy those airplanes based on geopolitical machinations. So I think so there's going to be a lot of pushback, and especially when you hit certain industries where, I mean, people have been, I mean, I'm not going to exaggerate too much on this, but people have been killed because they took their manufacturing knowledge and wanted to take it to another country. And creating a ecosystem where we want to take all manufacturing and make it distributed and making it open. There's going to be a lot of gut reaction pullback or resistance to that idea. And I think that it's important to keep that in mind as we talk about these things, that not everybody has the same perspective on why it's a good idea to open up manufacturing for all goods and services. There's already people looking at ChatGPT and AI as, oh no, you can ask ChatGPT how to make cyanide or cyan gas or sarin gas. And you're just like, well, it's already on the internet, but it just makes it easier. Like, how do you balance the two, I guess? And I think that a lot of it's going to be, I think a lot of it is that where we're going, I think, needs to be conscious, but also as radically open and transparent as possible, to let these discussions happen and then maybe find the edges where there needs to be more regulation or where there needs to be less regulation. Because I mean, we're going to...
there's been a lot of stuff around weapons, especially in that context as well. And that's one of the things here. I'm based in the UK, and there's in recent weeks there's been a lot of talk. Basically, there was the first actually I think it was in the Netherlands, I think 2 weeks ago. It was like the first ever case of somebody being prosecuted for possession of a 3D printed firearm. So
there's a whole community around 3D printed firearms, and and I think that, and I mean, there's a dangerous slippery slope in terms of how do you regulate, how do you create a society that can both safely handle dangerous ideas and also be trusted to maintain a reasonable expectation for a civil society. And I think this is a problem that's not going to be solved by this body or this group, but I think in general it's something that needs to be considered, because we're going to be influenced and affected by that conversation in ways that we may not expect.
Yeah, absolutely. I think, talking about things, like how does this affect, as you said, how does it affect, I mean, human rights? How does it affect freedom of speech? How do, there are so many different areas, and we do need to be very aware and participate in these conversations, wherever they're happening. I agree, the IOPA might not be the right forum for a lot of these things in certain contexts, but maybe it is in others. So, and that in large part depends on how the community grows and what the community wants to. I mean, what we're trying to do is find those needs and make sure that we're meeting them in a way that's moving everybody towards that goal of getting as much distributed manufacturing out there as possible. And I think that is one of the, this comes back, in my mind, it comes back to the use cases where I agree, there's been centuries of economic and social and so many different aspects of sort of how we've developed over the last couple of centuries in particular has been around this paradigm of manufacturing, basically. whether it's to do with the legislations, as you said, legislations about, import, export control, supply chain management, all that kind of stuff. It's all based on this particular model of manufacturing. So shifting that is no easy task, basically. And it is about identifying the industries, the use cases, the specific products that make the most sense given where we are today, to focus on and build out from there.
I think one way to think about it too is that the industries that are going to be most affected by these are going to be the industries that are going to be most affected by digitization of their products.
Yeah,
and I think this might be the way to think about this. Maybe the ones you hit first are the ones that are most at risk for disruption. Because one of the problems that you're going to this happens a lot in like financial industries, or people that have like investments or community investments inside of an idea, but they have like a lot of it's easier to basically replace an existing body's primary bread and butter with another bread and butter application than it is to say you have to go out of business.
Yeah.
Because if you tell them that, it's like the oil and natural gas industry. If you tell them you have to stop making oil and natural gas today, and you all have to go out of business, and everything that you ever have done has to be thrown into the waste bins of history, you get a lot of resistance. If you tell them, I want you to convert from doing oil and natural gas to making nuclear power plants, and we'll help you do that, and we have a regulatory process for doing that, then you will get a lot less resistance to the act.
That's true.
I think that's one of the things where I think the IOP could be very useful, is in helping industries transition as they come across these disruptors.
Yeah.
And making sure that the value of the disruptor does not get lost in the human aspects of the implementation.
Yeah.
And also because unfortunately, I don't think government bodies are really designed to support this particular application or this particular goal, because most of them are also regionally based. So you'll see protectionism against disruptive innovation than acceptance and then mitigation on those types of ideas.
Yeah.
So I could see that being a good way of kind of conceptualizing, like, what do you tackle first?
True. Yeah. And and I'm really, again, very much looking forward to sort of expanding on these conversations and seeing, I think, there's still quite a bit of interest in, for example, when it comes to medical devices. That was, one of the things that came up in today's call earlier. And, I know that a lot of this is kind of the long tail of the pandemic in some ways. There was a big rise in interest in looking at sort of distributed manufacture of medical equipment and protective PPE, that kind of stuff. And I think that there's still some inertia that's been maintained, but it's obviously, I think it's been waning slightly. But I think that there are still areas within medical manufacturing in general that I think there's an appetite for these conversations, because it is a big challenge for a lot of people around the world to be able to get their hands on the right equipment at the right time.
Yeah, and primarily the way to look at the medical industry right now is that the medical industry is regulatory captured by mostly large money firms, because the problem is that doctors have very little selection in what they use for PPE and for medical hardware. Hospitals also, oddly enough, have very little direction in what they can use for materials. Because everything gets dictated based on the FDA's, or in America at least, they get dictated based on the FDA's decision-making process. And so, but the thing in the FDA is unfortunately regulatory captured by existing large money firms, primarily because they've created beneficial roadblocks which sound good to the public of like why they need to have them, but they've created large roadblocks in terms of new entrants into the field, so they eventually collapse into a small body of well-heeled manufacturers and distributors and intellectual property generators, such as drugs, materials, and goods. So I think what IOP could basically do is they could create a you know how like are you familiar how like the how other bodies act as basically as a watchdog group?
Hmm.
I could see the IOP working as a watchdog group for these industries to help encourage and promote change to allow for distributed manufacturing in the medical industry to
Yeah.
help, well, or to recorrect or rebalance the distribution of power in terms of who can manufacture material, goods, and services for the medical industry.
Yeah.
I mean, and a lot of it's based around this concept that everything has to be like safe and secure. But in some ways, we've actually created our own worst nightmare where we have superbugs in all of our hospitals that have no treatment because we have claimed them to the point where there's no beneficial bacteria ecosystem inside of the hospital. We've created basically a perfect petri dish for only the most virulent and pathogenic diseases to be able to survive.
Yeah. Yeah. That's true.
So I think there's a lot of really good use cases for like how to basically turn or use the IOP as a platform for highlighting and then using it as a way of saying that distributed manufacturing can be a solution to some of these problems.
Yeah. Yeah, true. And I think, what I've seen as well is, and it came up again today, is the, looking at repairability as one of those pathways into distributed manufacturing, where it's, whether it's medical devices, agricultural hardware, electronics hardware, etc. It's, when we look at the manufacturing of parts, so it's much easier to sort of speak to and I think Toyota had actually done some experiments along this a while ago, but I'm not sure, actually thinking back, why they stopped, or at least as far as I'm aware, they stopped these experiments around creating these cars where some of the panels and some of the body components were basically open source designs. So the car was still produced by Toyota, but then you could sort of, once it's distributed wherever it's sold, you can locally manufacture parts based on these open sort of essentially, as long as they comply with certain parameters of how they're being fitted, then you're free to do whatever you want, and you can sort of, it opens up a lot of scope for personalization and of course repair. And I think especially in agriculture, that's particularly important, because being able to get that part made down the road and available within 2 days, as opposed to having to wait 3 weeks for it to be shipped over, can make or break whether you actually get the harvest that year or not. So these are some areas I feel that repair in these industries. And as I said, same with medical. I think if you're replacing a specific part, that regulatory capture becomes not necessarily, it doesn't go away, but it becomes less of an issue depending on which part you're talking about.
Yeah, and there's creative ways to basically get around some of these issues. The number one easy one is to move outside of a regulatory environment that is as restrictive, and or that is not market captured yet. And there's a lot of other places around the globe that could benefit from the engineering and efforts that we're talking about. The other one is that you can also make off-label uses that then become the primary, the primary use case. For example, for the there's one company, there's one open source project called the Papper, and it's actually interesting because it's basically an open source respirator. But I think that I was actually looking at doing an industrial version of a respirator or for intubation and for respiration and for all these other use cases, because they basically all use the same piece of hardware, which is a blower that can inflate the lungs of a patient. But if you can create a device that works as basically like a breath engine for letting you breathe easily while breathing in filtered air, you could create a device that could basically have both industrial as well as medical applications in an emergency.
Yeah.
So the idea is that you could you could bypass all the medical requirements for building these devices, and then open up the design and get them to market as a commercial health and safety device. But then build in the capability to be able to switch them over to being a medical respiratory device in emergencies.
Yeah.
So the idea would basically be look for opportunities where you can create a basically like a public or like a commercial medical buy application, and then by an emergency you can switch over to the medical application during times of crisis. So one use case is that you could have like you could use these for like health and safety, and a city could like have like a whole supply of these that they could just keep on stock. And when they need to deploy them, let's say that you had like let's say we have another natural or a man-made disaster, like you get a building collapse, and you need to basically get respirators for people trapped underneath rubble quickly so they don't suffocate on dust and debris.
Yeah.
You can hand these out to people, and they'd be battery powered, and you could basically get them breathing while you rescue them.
Yeah.
But you could see that as something that if you could do a call to arms and have everybody who's in manufacturing donate their breathing apparatuses that they're using in other industries to this cause, and you can basically see like there could be like a once you have it's like having like shovels. Like if you had another use case for your shovel besides when you have a medical emergency, then you could pull from the shovel supply to feed it in. So having these special only used for medicine devices means that if it's there's no real like turnover in application. Yeah. So anyways,
no, it's true, and I think, I mean, it's you know, what I think this could, you know, this could definitely lead to sort of a conversation around, you know, documenting all of these use cases and sort of identifying the projects that can work in these different sort of scenarios, and then, as I said, and sort of build from there in terms of bringing together the communities that are interested in actually sort of testing these ideas out and hopefully building, you know, whatever it is that we need. You know, sometimes we might need standards, sometimes we might need specific sort of tooling, or as you said, sometimes we might need specific processes in terms of, you know, a watchdog or, you know, legal entities. I mean, this federated warranties idea, you know, would need
framework to quickly implement them.
Yeah. So yeah, I think so I'm going to be taking a few notes, and I think this is where I think sort of we'll have a bit of a think internally, basically, in terms of sort of how we can take these conversations for, like how we can structure these conversations in a way that actually sort of brings the right people into the room to talk about them. And I think part of it is this sort of category, you know, how do we split these conversations up, basically, because I think it is at some stage we need to split them up into sort of different work streams to make them more sort of focused on particular outputs. So yeah, I mean, I'd be, as I said, it'd be great if, you know, I'd look forward to getting any information that you have, especially any notes that you can share about the federated warranties idea, and yeah, invite you to sort of join the, if you haven't already, have you joined the forum already, or?
I think I made an account today.
Yeah. And yeah, hopefully we'll see a lot of these conversations around these different use cases, and really identifying what are the industries and or products that can really drive these sort of ideas forward as quickly as possible. And as you said, I think identifying the ones that are the least resistant to these ideas, or the more receptive to these ideas, is one of the key things. Yeah.
Yeah, and I think the other thing is that I think I need to look into more of the history of the IOP, but an organization like this is desperately needed, and I think we've all been thinking about these ideas for a long time.
Mm.
I've been thinking about these for at least since 2009, 2007.
Okay.
But it's just been swirling around, and it's just been developing and developing and developing. But as you notice, it takes time. It takes a reason to really bring them out and to see if that a better or larger impact. So I look forward to working with more people and creating a cohesive organization and a cohesive vision. I think it'll be useful for me, and I think it'll be useful for other people too.
Great. Yeah,
as
I'm
we both-
glad to hear that. I'm really looking forward to your contributions as well.
Cool.
Yeah.
Well, it's been a pleasure talking with you. I'm hoping I'll probably try to make more of these, and I guess I'll talk to you later, and have a nice day.
All right. Thanks.
Bye.